The displacement vector, on the other hand, what is it? Okay, so let's say we have again the uh, x and y coordinate. Let's say this is the y-axis and that is the x-axis. Okay, let's say a body is going from point A to point B, right? It is going from point A to point B. Now at A, what are the coordinates of this body? The coordinates will be x1, y1, and at B, the coordinates will be x2, y2. All right, so we can say that A here is the initial position of the body and B is the final position of the body. So if we join with a line from the origin to point A, this gives us the position vector of the body at A. Let's call this position vector as R1 bar. All right. And again, if we join from the origin to point B, then this will give the position vector of the body at B. Let's call this R2 bar. Understand? So if we just draw a line directly from point A to point B, from point A to point B here, directing from the initial position to the final position, we get delta R bar. And what is this delta R bar? Delta R bar here represents the displacement vector. Okay, it is the displacement vector. So here, displacement vector, that means it gives the position of point B with respect to point A. So you can say that it is a vector. It is a vector that gives the position of a body or a particle of a body with respect to any point other than the origin. Okay, it is directed from the initial position to the final position. All right. Okay. Let us find the expression of this displacement vector. So in the diagram, okay, in triangle AOB, do you agree or not? Just look at the direction of this arrow. You're starting from here, you're going this way, and then you're going that way, right? And here you're starting from here and you're going that way. So do you agree or not, if you go from O to A and then from A to B, that is the same as going from O to B? So in vector language, you can write in figure. In vector language, it means that OA vector, OA bar plus AB bar. AB bar is equal to OB bar. Yes or no? It's very simple, is it not? You want to reach point B. There are two ways you can reach point B. Either you can go from O to A, then A to B, this one, or you can go directly from O to B, that one. So either way, if you go that way or that way, they are the same. So therefore, they are equal. Understand? So from here, can I write AB bar? This will be equal to OB bar minus OA bar. Okay, so what is AB bar here? AB bar is delta R bar is equal to OB here. OB here is R2 bar minus R1 bar. Let's call this sum equation 1. Okay, but what is R1? R1 bar is just like before. We already know the expression of the position vector, right? How do we write position vector? We say it is x cap plus y j cap, right? So here R1 will be what? Will be x1 I cap plus y1 j cap, and R2 bar, this will be x2 I cap plus y2 j cap. So therefore delta R bar, instead of R2 here, what do we write? Let's write this one, x2 I cap plus y2 j cap minus, and minus what? Minus R1, isn't it? So instead of R1, let us write this one. So minus x1 I cap minus y1 j cap. Okay, so can I take common the I? So if you take common I cap, you get x2 minus x1 inside of a bracket I cap plus, even take common y jj, you have y2 minus y1 j cap. Okay, so this is nothing but the displacement vector. All right, let's call this some equation 2. Okay, so how do we find the magnitude of this displacement vector? Remember, when we found the magnitude of this fellow here, what did we do? We just take x square, add with y square, and put it under root. Yes or no? Coefficient of I, so that means x, square of that, plus coefficient of j, that means y square of that, under root. So similarly, we can just take this square plus this square under a root. Okay, so its magnitude is delta R. That will be x2 minus x1 whole thing square plus y2 minus y1 whole thing square under a root. Okay, and I believe you are very familiar with this formula before in geometry, right? This is called the distance formula. Okay, basically why? Because it gives the distance between the point A and point B. Or you can write like this, delta R, instead of writing x2 minus x1, we can just write delta x square plus, here also you can just write delta y square under a root. What is delta x? x2 minus x1. And what is delta y? y2 minus y1. All right, so this gives the magnitude of the displacement vector. Understand? So suppose if in 3 dimension, right, in 3 dimension, what will be the expression of the displacement vector? We will write that in the form of a note. In 3 dimension, the displacement vector delta R bar, this will be x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Okay, and its magnitude will be delta R x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square under root. All right, so that is all for the displacement vector.